Good evening, everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects, titled Mathematize This, with Matthew Aldridge. We have a very large group tonight with mostly experienced users. Actually, almost all of you are experienced users, except I see Chira is new, but mostly experienced users. And Matthew is also an experienced facilitator. He has conducted a few OTF Connect sessions in the past, so it should all go very smoothly tonight. And as you will see, Matthew has planned an interactive session, so it should be a lot of fun. I would like to thank you all for taking time away from your families to meet us over OTF Connects and to share your ideas and expérience throughout this session. Et comme d'habitude, je voudrais profiter de l'occasion pour dire quelques mots en français et pour souhaiter la bienvenue à nos collègues franco-ontariens. Nos sessions sont généralement en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à me contacter par la suite. We are definitely thrilled to have each and every one of you with us tonight, mostly from the southern part of the province, but actually from all over the province actually tonight. And we're also glad to welcome Matthew Aldridge tonight with us. Matthew is a resource teacher of mathematics in the alternative program of the Peel District School Board. I've moderated for Matthew in the past, and I always marvel at his famous one-line resume. Matthew has a bit of a reputation, I think, for his one-line resume. It's indeed the epitome of modesty, I think. So in his own words, this is how Matthew asked to be introduced. Matthew is a father, educator, TEDx speaker, thinker, writer, and tweeter. And that's his famous one-line resume. And when he sent me that succinct one-line resume, he simply added, that's enough of a bio, I think, followed by a smiley. So that tells you a lot about who Matthew is. So Matthew, at this time, feel free to click on your talk button and to jump in and start the presentation. The class is yours.
Hello. So it's great to be here. I always enjoy facilitating OTF Connects webinars, and I enjoy supporting the fact that we have this amazing webinar series. And OTF is doing great things with professional learning, so I'd encourage you to keep doing them. I noticed the very next one is my friend John, called May the Force Be With You. A very, very important session about fractions, for example. But it's wonderful that several nights a week you can take professional learning on your own time at home. So welcome. I'm going to try and go slowly and let this session breathe. If you look on the calendar, on November 28th, I'm doing an early numeracy one, like primary number sense. That's more technical of a session. Tonight's is a bit less technical, and it's more about getting an eye for mathematizing things. So it's starting to see the math in the world around us and bring it into the classroom. You know, and quite specifically because pictures and images are everywhere these days because of our camera rolls. There's many more than ever before. It's easier to use pictures to kind of activate mathematics, or indeed to become the task itself. So that's where I'm going tonight. Firstly, so as Michelle said, I'm known as a tweeter. I do feel like, so hashtag Mathematize This already exists. And if I can explain, it's because last spring there was a series called hashtag Not a Book Study with Cathy Fosnot for 8 weeks. And you can look up that hashtag as well. And for that, they had a Mathematize This contest. So Cathy Fosnot is fond of having kids mathematize their world as young mathematicians. So, and people sent in pictures, and I actually won a book for one of them, which is amazing. Just so I can give a plug for this fall's version, it was called the Math Pod, and it just finished last night. It was 4 weeks with Cathy Fosnot, and Stephen Hurley. So the evidence is in hashtag #TheMathPod. That Twitter account as well. Also, the last Twitter chat is on Sunday at 8 p.m. But the link that you see on the screen will take you to that hashtag, and you'll see anything that's there. This link. And I'm not sure if it's live for you, but you will either copy and paste it, or if you are a tweeter, go to Twitter and put that hashtag. If you're not a tweeter, probably use that link. And so people were just sending in their pictures with their ideas of things that we could mathematize or turn into tasks for kids. So again, that was right there. But please do tag at @OTF_PD. You can tag me as well. But I just figured it would be fun to use this hashtag. It adds to what's already there. As you'll see, I use Twitter a lot, so there's at least one more hashtag later in this presentation. And so if I can just make one more plug for the non-tweeters is Twitter changed my life. So as far as my professional learning, my personal learning network. This one, so this one, I had credit in my slides. It was posted by, yes, Jill McAlpine on Twitter, which I think that link is coming. And it's a picture of a pumpkin from just a few days ago. Yes, there it is. Average pumpkin, ? So I was hoping that we can put into the chat box questions that we think that we might ask. Okay, so there's two routes you might go. You might say, well, if I put this out to my students, and it doesn't matter, you know, from grade 1 to 8, let's say, or grade 1 to 12, what might they say? What mathematics might they see in this pumpkin? Or what might they wonder? Okay, so let's get a whole bunch of potential questions. I already see you can start with questions like how big is it? You could start with how much does it weigh? So what is the circumference? Is great mathematizing, because I can tie that specifically to the grade 8 curriculum. And all we need is one measurement, and we could do some math. So what's the circumference and diameter? What's the weight of the truck if the pumpkin weighs X amount? And how many grade 1 students could fit inside? How long did it take to grow? And how many small pumpkins would fit in a large one? So that could be more the proportional reasoning. Volume and surface area. So we'd have to decide how to model it, maybe as a sphere or cylinder. And how many seeds? How many days did it take to grow? I see with some of them, you know, I picture graphing the growth of the pumpkin. How many lines did you see? What is the space inside? So proportional number of seeds. Bigger and smaller pumpkins, how much per gram? Radial pattern. So now the questions are flowing in. And so pay attention to what you did. You may likely have had your grade level in mind, and then that led to the sort of question. But just think of what would happen if you were to just put this picture on the screen for your students. Could you come up with the day's mathematics? And if the answer is yes, well, and you didn't need a textbook, and you didn't need any other resource, you just needed this one picture. Okay, well that's amazing. Keep that mentality in mind as we go through this session. I said I pulled that one because it was fresh from Twitter. I'm going to do some talking in this session, so it's not like a technical session per se, but I just find I can't do them without saying, well, these are the beliefs that I've come to about mathematics education. And so I spend a lot of my time reading and thinking about that, and just trying to settle on what I do believe. And so what I believe are maybe the true facts about mathematics education, or what's non-negotiable about it, what I truly believe. So a lot of times I use this quotation that you see. And if you ask kids, you know, what is math, which I often do, and you just give them that stem and you say, math is, and you just give them some sticky notes or a Padlet or some whiteboards and just get them to do that. We always want to know what would they say. And so Jordan Ellenberg in his great book, How Not to Be Wrong, which is the best popular math book, definitely one of the best. So it has no equations whatsoever, so it's not written for a technical audience. But he just refers to the mathematics as the extension of common sense by other means. When are you going to use it? And I just feel like I wondered if, well, if school mathematics were to focus on developing all these tools, like adding, subtracting, multiplying, and dividing, and all the other things we do, all these concepts of number, shape, space, luck and chance, working with data, if this was to extend our common sense, if that might be a more practical definition of mathematics for schools. I don't think it's an all-encompassing definition by any means, but I do like it a lot. Anyway, so those other means would be mathematics, whatever tools we have at our disposal, the things that we know how to do with mathematics. I just pulled this definition from the internet. This is definitely a real word. So mathematize is to regard in purely mathematical terms. I feel like we've made a lot of progress with not having kids think that mathematics just happens in math class. I think it's a lot less mysterious and obscure than it used to be. Like, say, before the internet, when you would have had to go to the library to find mathematics books, or you would have had to take your teacher's word for everything, because there was just less in the culture, right? There's more now. But I don't know if we're used to seeing the world with a mathematical lens, and I think that we could be. So I have this thing now where I'm just walking around, and I'll just have to take photos, because I'll think, okay, that's mathematics. So that's the mathematize this mentality. And it used to be, well, or I'll think I could do something with that in the classroom. So recently I went to New York City, and it was for something called the Global Math Project. And I saw this picture in Chinatown, and it's all mostly peppers and fruits and apples. They're fairly neatly arrayed, and it kind of actually coincidentally is a lot like Cathy Fosnot has a grocery store unit that's about arrays. And so you could just get this eye for neatly ordered things. And so we might take any one section and give them to kids. Anyway, I was just walking and I snapped this, and that's the mentality I want for us, everyone in the session and us. And to partly answer the question, I'll answer this one. Maybe if I was looking at, probably if I was looking at multiplying and you're building that sense of the neatly arrayed units or the neatly arrayed objects within an area model, I might use a picture like this. But sometimes it's nice to just ask how many, like how many green peppers. And as far as where I stand on thinking, this picture is just, it's actually a do-it-yourself laminated grid paper. Because whiteboards don't have to be high-tech, and they don't have to be expensive. But kids know that they can write all over them, because eventually you can erase it. It's not permanent. And so they're pretty comfortable getting their thoughts out there. And thinking should be messy. So when you see things crossed out on the page, I think you're doing something right, because we've changed courses in our problem solving. We're open to changing courses. And that's the kind of mentality we want. The thinking is very messy. A reference I can give, I'm not linking to it today, but Peter Liljedahl on Thinking Classrooms has a lot of current work and interesting research. Just Google that, it's easy to find. And a nice paper on things that happen in thinking classrooms. But he does note that vertical non-permanent surfaces, and then even horizontal non-permanent surfaces like whiteboards, kids are actually quicker to write, so probably the non-permanence of it has something to do with it. But we need to allow for these big, messy thinking spaces. That's very, very important to me. And some considerations about what is the real world. Because typically we say, well, mathematics should be in the real world. And if you were to follow along with any of those Fosnot kits that I've mentioned twice already, if you use them, she calls them context for learning, and they definitely are in the world. But problems like this one about the drama club are also in the real world. And so somebody has written a problem, in this case for some kind of textbook or resource, and they'd said 3/4 of the drama club members were girls. And so then 2 more boys joined, and now 5/7 of the drama club members are girls. But seriously, who counts like that? So I think we have a nice link to an interesting discussion in the Dan Meyer blog in the chat box. You know, I think there's good real world and there's bad real world. And I knew this was bad real world because I tried it. And so some kid said I would just put them in a line and count them. And it's true. Because your natural observation is not going to be, oh, look, now 5/7 of the drama club members are girls. You're just going to count how many people are there. So I think just being mindful of the context that we give. And actually, because kids sort of sniff out bad problems. And they want to call you on it, especially as they get older. I'm thinking intermediate grades. So I've given a few that were, no, the numbers were a little bit off. And one of them had to do with a shark in the tank. And of course, in like the numbers I gave, the shark's fin would be sticking out of the tank because my dimensions were off. And kids just love catching you on this sort of thing. But I think we have to be careful of, yeah, there's good real world and bad real world. And so don't accept it just as a given that real world is always better than not real world. There's a lot of interesting problems that just have to do with the mathematical world as well. You could follow that discussion at that blog link. I felt like, so further to my point about context, I just feel like it used to be, it has to have been much harder to find math problems years ago. You maybe just use the ones in your textbook, for example. But now we drive our cars, and so there's this interesting decimal context on signs all over. And so in this case, it happens to be probably about 2 years ago because it's 99.9. But I'm just looking and I'm thinking about that. And just today I was with some grade 7s, and one of them was just struggling with tenths, hundredths, thousandths. And so it was pulling together his sort of conception of place value in past the decimal, so in smaller increments than 1 whole. And so do these signs that are in kids' world help? So we have 99 cents and 9/10 of a cent. And I just wondered if it's that close to $1, is it really $1? And if you watch the numbers go up, is it like a race between dollars and liters, and how close do they stay? Yeah, so as to Debbie H., kids really don't get the decimal of a cent. And so if you show your kids the pump, and I believe Kyle Pierce actually has one on gas tanks where he's, Kyle Pierce on Tap Into Team Minds actually has one where he records the gas tank and the liters and the dollars going up. And it's a really interesting video because in that case you have the extra digit because it needs to be that much more precise, which I think is actually a certain law having to do with volume, Imperial Weights and Measures Acts or whatever it is. So all of a sudden there's this context. Now I have to tell a story from today about noticing because I currently spend a lot of time sitting beside intermediate kids and talking to them about math. So the teacher had some really great math games. And so one of them had to do with rolling a 10-sided die and then making a 3-digit number. And you do it 5 times and you're trying to get close to 1 whole. And this kid his actual number was about 1.1, maybe 637 thousandths. But he'd written it as 16, so 16.37. I thought, oh yeah, you know, like the decimal's just in the wrong place. And it goes to show the importance of noticing. And so he actually was counting by tenths. So he was counted from 1/10 to 16/10, which he saw as 16. So again, you can see with the place value units, it's pretty easy to get tripped up. Let's see, the decimal send. Actually, rounding from Debbie H at Tim Hortons is an excellent one. When does it round up and when does it round down? And when should we introduce this idea? So my experiences lately have been with grade 7 where the consolidation for some of this whole decimal world is not quite there. So yeah, grade 6. But then in grade 7 and 8, you could maybe go to look at the unit rates as well, like comparing the dollars per liter. And so I'd say in general, like the grade 7, 8 is starting that progression from, it's not starting, but they go up they grapple with some more abstract concepts and some new concepts. So I'd say sort of things like consolidating the decimal understanding starts to happen. But I'll ask you to think about just this one context. If you were filling up the tank, even just snap like a 5-second video filling it, or just take a picture when you're done or before you start, or just take a picture of the sign. I didn't use it today, but Aaron Mills Superstore, like Loblaws, near Aaron Mills Town Center, has, to this day, has the distinction of having a double decimal. So talk about messing kids up. So usually it'll be like 1.11.2. So they have dollars, cents, and then they add an extra decimal to help. But for those who have worked with junior and intermediate, you know that sometimes kids will try and add that extra decimal when they get messed up. But I think even just from that, the discussion in the chat box and things I've said, we can start to think in terms of contexts that are around us. Yes, I agree with Debbie H. It could be the gas price inquiry. Oops, that's the wrong direction. Finding interesting mathematics in simple things. This one, actually, some people are actually debating whether that piece of paper is three-dimensional. And it definitely has thickness. If it had no thickness, it would be just a rectangle, and so it couldn't be a piece of paper. But that said, it is so very, very thin, and so many of them make up even a centimeter. So just an example how you can just quickly snap a picture and just pose a thinking question. For this one, I probably would say, if we think in terms of that math talk, so starting the class to provoke something, getting specific about the mathematics here. So a plane is two-dimensional space, but we're always talking about a certain length and a certain width. So usually we're talking about regular polygons. We're talking about rectangles, triangles, parallelograms, trapezoid in grade 7, then the circle. But if it's not two-dimensional, it has thickness. So we'd be thinking of like a really, really flat rectangular prism. And we wouldn't think of this piece of paper in terms of that, but we might think of a stack of paper. And then, actually, I can say it for the second time, but I think one of Kyle Pierce's great tasks is on stacking paper. If you go to stack it, tap into Teen Minds. But he stacks the reams of paper in the package, which is really interesting. So again, just a thinking question, something to think about with geometry or with area. And sometimes with the math talk, you can just put something up on the screen to talk about. Just giving away another one for grade 8s. Last week we just posed the question just with a picture of each as a 4-inch pizza. Sorry, it's two 4-inch pizzas, the same amount of pizza as one 8-inch pizza. So, and it was sort of because of it's the power of the squaring. It's actually 4 times as much instead of twice as much. But in this, the teacher posed it as not as a pencil and paper, but as a talking question. Kids were amazing. Yeah, and we have students to generate questions. Yes, that's what we want. We want our students to be question askers. Problem posers, not just problem solvers. I don't believe I put a slide in for that tonight, but that's always top of mind. And my son last year in grade 1 came home and his agenda said, think of a math problem. I said, all right, that's my type of homework. This one, yeah, it shrank a little bit too much. But so the kid actually knocked the center out of the toonie, and he said he had $1 with the outside ring, and we measured the diameter to be 11 millimeters, and the whole coin being 28. And again, because of the circle area thing, that's probably, like, that's where my students went with it. So they said, no, it's actually, I think the outer ring counter, like sort of somewhat surprisingly, ends up being $1.71 just based on that. Not thinking of the materials, which the gold colored and the silver colored could be worth a different amount of money. So not thinking about that. But that was sort of an example of where we made the circle unit come alive. You know, there's a lot of old problems in old textbooks where you have an outer ring of something and an inner ring. But in this case, we actually had it in the world. I have no idea how we knocked the center out of a toonie. I suppose it must have been on purpose, or if it was a faulty toonie. Anyway, if you can have an eye for capturing moments like this, you'll never be short of math class, questions for your math class. And it's just always, once you start looking for them, I feel like I just feel like they're kind of always there, which is a great feeling. One thing I'd said here was, oh, I had these dice. And so, well, okay, you could, how many is an amazing stem, sometimes for primary, but it's sort of like if you're trying to get from adding to multiplying. With this picture, you could be, but let's say if it was a grade 2, maybe it's more about adding. Or perhaps you can think of other things to do with it. But just snapping a picture of something and saying how many. I don't believe I included it tonight, but I had another one that just was in a banquet hall. It was these neatly arrayed glasses just ready to go. And I think it's a 9 by 10 grid, but so it was a neat array of 90 glasses. Anyway, this one you could do as, I said how many provocation, but depending on the grade. Another quick little starter question. So how many is a just starter that started so many great problems, and definitely could. Okay. And here we have, this one came from, I didn't put the link, but it came from Donna Miller Fry on Twitter. So I always like to say who did it. So it came from @FryEd on Twitter. And really interesting. Again, this would be like classic Fosnot almost. She has those black and white line drawings, but all of a sudden we have the muffins in the world sort of updated and fresh. Well, they were fresh when they were baked. So a 6 by 8. Yeah. And forgetting the size, some of them are actually quite different. But so all of a sudden we have a visual anchor for 48, and we have an array for 48. If I can just mention another hashtag. So some people tweet to ArrayChat, hashtag ArrayChat, because they really love arrays. But if our number fact for that day, and maybe we're in grade 3 or 4 and we're working on those number facts, perhaps we would look at this, or maybe we would look at some kind of doubling, halving, or even quartering of this pan. I have seen amazing things with just a chessboard, which is 8 by 8. So just a picture of a chessboard. And I'd say maybe for things like this, how many provocation, yeah. But so bringing multiplication facts to life. How many different ways can you count the muffins is amazing, because we're going to go back to skip counting, I think. I'm reminded, depending on the student's sort of facility with iPads, if they all had a copy of this picture and anything at all that draws on the screen, they could mark their counting, which would definitely be a different dimension. Google Classroom for older grades. Just make sure I'm not missing anything. Okay, so I think we can see how we can mathematize the muffins. By the way, your regular, I think, is probably 4 by 6 arrangement. So 12, 24, and 36 are actually highly composite numbers, and that's why there's so many problems based on 12, 24, 36, 48. They just have many factors, and 24 is the first one. So you could spend a lot of time working on 24, especially as you're on that landscape as you move through adding to get to multiplying. Yeah, so as Debbie says, kids can mathematize. I've seen a lot where people go around, there's one where it's the angle hunt, where they just walk around the school with the iPads. I haven't seen it in person. I'd like to. Sounds really cute. But then it's just walking around and doing a math walk. It's another thing I've heard of. So take the pictures, make some math with them. Okay, this was where we need opinions, and we'll definitely just use the chat box for this one. So we have this buzzword inquiry, and we actually have these 3 monographs in Ontario. Teacher inquiry, collaborative inquiry, student inquiry, I think. There's 3. But so what do we really mean when we talk about an inquiry classroom? And there's a few things on the screen that we think it might mean. But I think taking a stance on what it means to inquire is important. So get the time right now for the next handful of minutes. Let's get some ideas in the chat box of what we think inquiry means. Okay, investigation comes up, and I will hold that thought and talk about that in a minute for sure. Just as more ideas come in for the next couple of minutes. So there's really nice stuff, and investigation and investigate just keeps appearing. So mathing can be a verb, right? So investigate is one of the best verbs of that. But we need to be attentive to when the curriculum asks us to investigate, or when it's appropriate or even just interesting to investigate. So if I say investigate with, how would I phrase it? I'd say investigate the Pythagorean relationship with square tiles. That might mean attaching squares to the side of different triangles and trying to find out seeing what we notice, but trying to find any kind of relationship. So investigation can be the beginning of a lot of amazing inquiry learning. I definitely agree. Student-driven and student-led, so we see a lot. And to me, it means really open problems. When students are questioners, not so much us. Collaborative construction of knowledge for sure. Investigating something you don't already know the answer to. And that's just one of the amazing things about mathematics, that we can just do that over and over. There's always something to investigate. As a matter of fact, at the highest level, there's many unsolved problems in mathematics, many, many, many. But approaching it like mathematicians, being inquisitive, solving problems that need higher order thinking skills, so students creating their own understanding. Inquiry could be as simple as is a rectangle, a square, and I think that's a key point because again, given this mathematize this mentality we're talking about, just show a picture of each and ask the question, and what kind of reasoning do we get to? And that's actually something where I love simple questions, and my task was always, can I ask a question, can I pose an interesting mathematics task in as few words as possible? And the answer always seemed to be yes. And I got frustrated, those paragraph-long questions, and I didn't think they really needed to be that way. So if I give a powerful image in a sentence, is that enough? And sometimes it is. But it happens to be, is a rectangle a square, or vice versa, happens to be a really big and interesting idea. So students guiding their own learning, hypothesizing and exploring, discovering about mathematics through investigation, which is always an amazing point. And having listened to Cathy Fosnot again for the last 4 weeks, she's right there with you. But in the example I already gave as well, like Pythagorean relationship, yes, oh yeah, well, it was discovered several times, not just in ancient Greece. It was apparently discovered even well before that, and it just has slipped my mind where. And like a few concepts, they were discovered independently for the first time in different parts of the world. So pi is a good example, different values for pi. But, so there's nothing to stop us from having kids find something for the first time. And so it's as if they discovered it. And so sometimes people will get a little angry about this and will say, well, that's already been discovered. I mean, literally, they get angry. And they yell at me. But to a kid, you have made that discovery. So it is as if you are Pythagoras or whoever. And so I've always figured that's got to feel good. And you, of course, help them to figure out what it means. Creating living mathematics instead of studying dead mathematics, thanks to Cathy Fosnot. Yes, the vitality of the living creation of mathematics. She really inspires people with that. Teaching students to be critical thinkers, top of Bloom's taxonomy, create their inquiry. So ownership drives learning, and that just becomes a mindset. And that's true. So if you have that kind of classroom, kids will come up to you with the broken toonie and they'll say, hey, I have $1, and you can investigate that. And I think those are truly thinking classrooms, and so kids will sit back. If they know that they just have to interact with the worksheet or with the textbook, they will sit back and they will be less interactive because they'll start to know that that's all they have to do. But if we expect them to talk, reason, conjecture, wonder, they'll start to do that. Thinking is hard, but I've found that kids just generally want to think, in some cases more than adults. Thinking of time, so there doesn't have to be like long time frames to inquire of something. It's like mini and quick ones. Numberless graphs is a great idea. How is art math? And then you inquire into it. That's a good example of where research could come into it. Things like the golden ratio. Yeah, and you can structure it as you like. There's actually very wonderful responses. So I think that we can see mathematics classrooms as inquiry classrooms. We should, and we must. I always use this slide because my concern is how much guidance should we give and when should we give it. So at the one end, so some hypothetical line with two poles. At one end is fully guided instruction, probably where we just guide everything. We don't leave too many decisions up to kids. And then at the other end is unguided instruction, where, well, even if they discover something, they're not going to know because we're not explaining. And my point with this, and yes, the blog that's now linked, is I want educators to know on any given day, where are you on that line? It's not really some kind of polar dichotomy with different these lines. It's not really like that. So there's not too many people who fully take every decision away from kids. And hopefully there's nobody who doesn't explain anything ever to kids, right? Because it's sort of, we may as well not be in the room in that case. Our expertise is needed. And so I'm just asking on any given day, for any given task, for any given lesson, so what are you doing? And so if it's the consolidation part, if we're doing is a square or rectangle, for example, let's say kids have drawn out some ideas. The unguided part is probably that exploring it and talking about it. But the guided part could be the powerful sort of 10, 15-minute consolidation at the end, where I introduce some ideas about squares and rectangles, or maybe help get the definitions on the table that we need, okay, just for one example. And we leave sort of having a better understanding of that concept. This line, so do you mean this, so do you mean this line represents little or no scaffolding? Yeah, in a sense. I'll give a bit more context. There is a paper by Sweller, Kirshner, and others, and sort of it's kind of the main line of attack. It's called the failure of minimally guided instruction. And so there are the big advocates for, I guess, explicit instruction. And so I'm not an advocate for daily, all the time explicit instruction, but they're trying to say this inquiry, this discovery math has failed. And that's the main paper there. For full guidance, there's a few different programs that are used. There's even scripted programs. There's things like maybe, yeah, there's different programs that give all kinds of scaffolding the whole way. And I was just asking us to be mindful of what we're trying to do. And so the first thing that I always have in mind is with any given concept, you can do something to open it up in a big conceptual, interesting, hopefully visual way. There's not too many places where I think, well, you're going to say, here's your formula. You know, that's maybe more on the full guidance side. It's more like, well, find out something, develop the formula together, and that could be the guidance. Yeah, so the point here is that just be mindful on any given day. Read that blog if you like. I was trying to say plainly that we have to know what we stand for. I hope maybe this tweet that I included will help clarify. So my friend Tim said, you're a 7.5 if one is full basics. So again, we have that definition of just like back to basics curriculum. We might associate it more with worksheets and algorithms. Maybe, but 10 being all inquiry all the time. He called me a 7.5. I said maybe time-wise, that's probably about right. I'm not going to spend more than 25% of the time probably on the explicit teaching aspect. So I just don't believe in talking that much, especially in elementary. But so we get important points coming in like Melanie. So guidance most for notation and conventions and aspects of math. That's stuff we can definitely give guidance on. Also need to know their background knowledge. We definitely do. Oh, and the curriculum before the grade. Thank you. So thinking of mathematics as extremely developmental. Further, I always say classrooms are open spaces for thinking. There's actually a nice paper by Chris Sertam which echoes the same sentiment. Although I did have a blog called this years ago, but it's just kind of coincident. But I say, you know, given that open page and some problem solving, kids will surprise you with their thinking. That's what I always like to say. We just have to make sure our classrooms are open spaces for thinking. And I always think I'm doing that. But I had an interesting experience about a week ago where a kid was reasoning through some math, and I just could not see what he was trying to do with his numbers, right? And I tried to redirect him. And sure enough, though, he was trying to do something like really important that he knew how to do. And so we have to be mindful of, do we shut down thinking or do we extend it and help with it? That was my big awakening. I did not intend to do that. And then I was thinking, how many times do we just do that by accident? You know, and we don't, I guess, honor a kid's thinking. Just be mindful that classrooms are thinking places. My favorite quotation is because, and it does come from Teacher Collaborative Inquiry, and that's the quotation that I had marked in yellow because I was excited. So if you were to do a co-teaching cycle, say, with some of your colleagues, you would be really focusing on kids doing math, and you might leave saying what this participant did. They said so much of their math thinking isn't making the paper. And that's just such a massive assessment takeaway, such a massive, massive thing, that if we want to know what they're thinking, we should just ask them. We shouldn't just rely on the paper documentation. If it was today and I said, okay, well, this is decimal addition, and I got, you know, it was 0.8 something and 0.7 something, and it came to 16 point something. If that kid, if I wasn't sitting right beside him, I wouldn't have nailed that misconception. Now, I might have just marked it wrong. And if I'd remembered, maybe I would have asked later. But as it was, I was able to just ask him. Just ask them. And from the assessment perspective, I'm just thinking of that assessment triangle with conversations, observations, and products. It's so important to just ask them. I like spending some time on the philosophy of where I'm coming from, and hopefully if I do that, you'll just join me in this whole Let's Mathematize the World venture. This one is about rich tasks. Everybody's talking about, where can I find me some rich tasks? I know, because I did a job where people ask that almost every day. And whereas there's a number of amazing resources you can send them to, lots, websites, amazing. But I really think, in the quote, I just wrote a couple thoughts there and just captured it, that we make them by knowing our curriculum, and we make them by asking interesting questions and letting kids think, talk, conjecture, and wonder, and of course ask their own questions. And so we have this thing where, well, we often talk about the three-part lesson. I say, well, what if that's just less a prescription or a template than a mindset? So what if we do have this amazing investigation going on, and what we thought was the minds-on turns into the whole game? But that can happen. And I don't want this sense that there's these rich tasks out there, that there are these events. I don't want people to think that's a thing in itself, because it's not. There's no rich tasks without rich context. There's a nice paper on Enrich, the website, and it's by Jenny, I think, Piggott, P-I-G-G-O-T-T. And she says that. But we know it's true. But those contexts are the thinking contexts. It's what we're doing with the mathematics. It's our learning goals, for sure. It's what we're doing attached to the curriculum. It's what big ideas of mathematics are there. And it's if kids are talking, thinking, conjecturing, and wondering. Just outline what I think about the context. So let's say, okay, well, don't just think of this as a checklist for a rich task. By the way, we used to do that. And the ministry used to give out stuff. So, well, if it has all this, it's a rich task. But really, are kids talking to each other, thinking, reasoning, wondering, proving, questioning, using intuition, thinking, and of course, thinking. Those are rich contexts. Those are the contexts that we always want. Okay, that said, just a few ideas to review for sure. And we can decide if our picture method, if just posing mathematics through a picture is going to get us there. Accessible, low floor, high ceiling. And I personally just read Lifelong Kindergarten by Mitchell Resnick. He says low floor, high ceiling, and wide walls. So there's yet another thing, wide walls. But allowing for different strategies or method, so they're not penned in by method or strategy. Intriguing starting point. A lot of pictures can do that for us. The math that emerges is intriguing, encourages creativity and critical thinking, hopefully. So those are some things to think about. Oh, and this was actually in here. So think of a problem. Give me a problem, not an answer. But we've got that point on the table. So lots have said, let's have the picture. Let's ask kids for their wonderings. Okay, and we could call that the what could I do that mentality of math planning. So as we get towards the end, we do want to get to more interactive parts. So for this one, I think we'll just use the chat box. Anything you could do with this picture of eggs, egg math, just put your ideas for egg math in the chat box. Curriculum area, fractions definitely come to mind. Interestingly, with fractions, we are actually thinking of parts of a set of the same object, which is good. We don't do as many sets. So ratios and percents. Perhaps some kind of adding and subtracting. What I want for all of you in this room, you get to the point where you could open your fridge and plan your next day's math lesson. I want you to be able to open your fridge and plan your next day's math lesson. That could be your next challenge after leaving here tonight. Fridge. How much cardboard is needed? Yeah, there's lots of interesting problems to do with packaging. And now, this is one question only. It's 5/12 of an egg carton if you choose to see it that way. Or 7/12 empty if you choose to see it that way. But I want you to have that mentality. Open the fridge and not say, what could I eat? But what could I do with that? And we already have how many glasses of orange juice can fit into the OJ container? Containers have a lot of information. We have a few examples coming up of that, so that's definitely snap a picture and go. 101Q's link will be coming up. Let me just look at the time here. Yeah, you know, we're going to do the same. So this is actually, I think to this day, it's the most popular picture on 101Q's. And it was posted by Dan Meyer, I believe. It's, subitizing the eggs is awesome. Yeah, and it had something like 100 questions. And you could go to 101qs.com and see the penny pyramid. Or we could just come up with a couple of our own. So if you want to put a couple of your ideas for the penny pyramid, and while you do that, I will drop the link in. I think I forgot to give it to Michelle. Actually, there's 81 questions to this day. How many pennies there are? How do you know? I think we can, oh yes, I have given you the link, pardon me. I actually forgot I sent in a page full of links. So there we are. And I just forgot if that one was there. So the community at 101Qs, so people do submit questions and then people will either add to them or skip them. So you can see what people commented there. I think what is the value in dollars is terrific. Slight tangent here. So I haven't fully read because I was saving the article, but using some kind of technology, they now know that there is much more open space in the Great Pyramid, which is also a square-based pyramid. I have no idea what ancient Egyptians put in there, but there's apparently this whole space that they didn't know. Perhaps they thought it was solid. But now I'm thinking, is this solid with pennies? Okay, this is another sort of realm as we get into estimating. So our reasoning includes the estimation sense. And so depending what grade you're working with, you'd be thinking of orders of magnitude, I think. And so you'd be thinking, you know, is it hundreds of dollars, thousands? Nobody knows how the Egyptians did it. There's more likely theories than others how Egyptians built the pyramids, but we're not maybe totally sure. So this is the realm of math where it's estimating, and so we're more thinking, well, if I just say how many dollars are here, how many dollars in pennies, kids are going to need to take some measurements or some visual sort of anchors, and for the bottom row, some kind of calculation. I think in the end we'd want to know, is it reasonable? So if we ask that question, so let's say some kid said, I don't know, $678, can we say if that's more or less reasonable than if somebody says $1,678 maybe? So a different sort of math where it's estimation that's required. And indeed, the links are coming, but Estimation 180 is a whole website involving pictures. Okay, the next slide feels, no, it's not out of place because it's the mentality. So the links coming up to that time, so we had 6, 7, 8, and we did unit rates and proportional reasoning for one of those ministry video projects. And I'm still, to this day, I'm very proud of it, and it's because this was the question. That's the question right there. And so I just took it at the movie theater and turned it into the project. But it's the mentality I want for you, is where we started with this one question. The kids' reasoning was awesome. But we had a lot of fights about fairness. And then we wanted to expand outward, and we wanted to look at flyers and different size containers. Okay, and so the secret I'll let you in on was the ministry folks came back and they're like, we're not sure about pop. I'm like, look, nobody's saying that kids should drink pop. I'm just saying that this is in the world. That's it. And sure enough, by the way, water inquiries are amazing. So bottled water inquiries. And probably from a social justice perspective, that's a lot more important of an inquiry topic. But this is what I picked because it was the night before the project was starting. And so I went to the movies and I saw this. But it was this, I want to say, it can be this low-key in the planning and lead to the sophisticated thinking. Low-key, but attached to the overall curriculum expectation about proportional reasoning, a big idea that some unit prices are more or less than others. So feel free to take a look if you like. Notice in water protocol to develop questions. This one we are going outward to a Padlet. So there's actually two different things in the Padlet. One is this, so kind of beside it, you can put your noticing and wondering. So let's see, do we have it? Yes, so the Padlet. And then if you have that link leaving tonight, you can just take some of the ideas. And I believe this is last fall's pop display. Just so, well, I'll let you notice and wonder. I believe it's the ordinary 12 packs. So again, it's a pop example. As noted from David S., kind of silly to be politically correct. Probably. I was just trying to say, things are in the world, let's use them. And yeah, that's important. So let's get some noticings and wonderings. And we'll just go outward to Padlet for just a couple minutes. Yes, and so Nicole C, we had something coming with the price per unit because of Costco math. In the Padlet, you can actually click on the pictures so you can get a bigger version. What I will do is I'm going to move this other one out of the way. Find what fraction of Santa is red could be quite an enjoyable one. Okay, and just as you've finished putting ideas in, as the next slide, I put the one about I wonder what fraction of Santa is red. How does that compare to how much white or gray? Let me go back to the picture. It's actually because his hat is round. It's definitely less than 1/3.
I just put it in that.
Oh yeah, perfect. Oh, and there's the whole thing. That's wonderful. So there's some evidence of the whole thing. I picked, just for this moment, well, okay, what if we're on our fractions pathway? I wonder what fraction of Santa is red. Yeah, you could do something with that. I noticed there's maybe a few bits in the bottom right that are blocked out, but I think you could be pretty accurate. And then you're going to things like equal fractions, denominators. Really, it's a lot like an area model, but there's that sort of array element to it. I know it's not neatly arrayed, but you could chop it up into squares or rectangles as kids do their reasoning. So all of a sudden, we could attach it to a few ideas in the curriculum, for sure. I just picked up on fractions, but you could take a look at all the other ones. There's lots of ideas of space and height and rearranging them, which is really interesting. So watch for these interesting displays as you go to grocery stores this fall. Yeah, I know. I did pop again. The picture's just interesting. And my reputation is not improving with the next one because I took pictures of the Oreo cookies. But again, like, you could do any type of product, don't worry. But Costco, I somewhat jokingly called the Temple of Unit Rate, and you can search that hashtag because we did 2 PD sessions, and that was actually with PL teachers, with some instructional coaches and myself. So, okay, well, let's walk around and make some math. Some of them posted to that hashtag. And so, again, my fascination was with the tag and the information it gives, because there's always a unit and a unit rate. And it's just really interesting to see what they sell it by. This one I came up with, how many cookies are there? How much are they worth? And of course it's 1.48 kilograms for $8.99. So, well, that might be interesting. If you were to get in close, there's actually enough information to see that it's roughly a cube. But Costco, like, believe me, it's incredible. The other place we did this was at Lowe's. So Lowe's or Home Depot, you get, well, I think you can spend a lot of time just with the screws, so because of all the fractions. But there's a lot of things like board feet, how they sell boards. There is so much. There's paint, cans, surface area. Oh, by the way, if you're a grade 6 teacher, EQAO loves asking about kids painting walls, because nothing says being 10 for as a context like painting walls, right? They do it all the time, sarcastically I say. But you could actually take a picture of the paint can and at least try and make it real. But do think about Costco if you have one in your local community. Yeah, EQAO loves kids painting. This one, well, we'll take the 3 or 4 minutes for some ideas. Look, I don't know how old your school is, but I go to some pretty old ones. My favorite is old high school math prep rooms because they have the most incredible old textbooks in one place. So I opened this one up. Okay, so at the time, the 700 film 50 milliliter, it was when they had those glass bottles, right? It was 49 cents. And then 24 tins. And that was the, oh, it doesn't say what drink it is. And it gives the unit cost. But sometimes you could say that, how can we freshen up this question? Oh, yes, I forgot about the provocative title. There are no current textbooks. So I think that, look, one thing you need to know right now is that, sure, we pull some questions from our Nelson and our Math Makes Sense, because there's some good questions. But the curriculum's moved on, and some of them weren't that well correlated in the first place. I'm looking at you, Math Makes Sense, grade 7, which I think was the first one. Not so curriculum correlated. It just didn't, I think it might have been written slightly before the 2005 curriculum. There are no current textbooks, so we have to be resourceful. So you can't go to those day in and day out. And it's a fact that they're not coming. Okay, so Pearson has a new thing coming called Mathology. I got a sample. It's a big box. There's activity cards, but more so there's differentiation in the questions. More so there's developmental pathways that kids could take. There's look-fors for common misconceptions. It's all there. It's worlds beyond a textbook. So knowing that there are no current textbooks, we have to be resourceful. Actually, I'm glad other people have done some work. Grade 8 and grade 6, Math Makes Sense, do have some good stuff. And actually, by the way, the Math Makes Sense Grade 7 has a terrific integers unit with 2 color tiles and number lines. But we have to be really resourceful and discard the bad bits. MathUp is, just in the chat box, is a Rubicon online platform. I've seen it for like 5 minutes, but I do know that there is a number of online platforms. And not speaking to MathUp specifically, but speaking to the online, the responsiveness of these platforms, like from an assessment sort of basis, is only going to go up. So in that sense, they're only going to get better. So it'll give kids the questions they need, essentially. So I think the promise of them is starting to be realized. One that I happen to be an ambassador for is TVO Empower, which is Data 6. It's just another one, okay? So it's another one in a very, very crowded field. So Dreambox, MathUp, Athletics, and so on. And then so there's certain ones that just do certain things, like IXL is more, as I understand it, the drill aspect. That's sort of, those are a dime a dozen. But ones that do good sort of assessment are harder to find. Consider learning about Empower. I think I'm going to leave my point. I was going to do Padlet for this one, but I'm going to leave the point. I think if I was freshening this question, I think that, you know, if you actually walked in the grocery store and saw like what types of containers are drinks sold in, it'd be interesting enough to just capture all those different sizes. Here in Canada, we have that 1.89 liter, and so kids would never know that it's a half gallon, right? And why not 2 liters? Well, because 1.89 liters isn't a half gallon. Right, so we'll leave that one there. I think if some could respond to David F. as well in the chat box. I love aquarium questions. I might get them to open up Minecraft and build your aquarium and put fish in it. No, I could see all kinds of questions. I'm going to let others respond. Just as we're getting towards the end, I want to have you dropping some of your own in Google Slides, and then at the end, as the outtakes, there's some more pictures. Because I thought, okay, well, if you leave tonight and you have one picture provocation that you think you'd use, that's great. You'll have the Google slide deck, so if you can just have that, and maybe there's something you'll use. This one, $1 million coin. Yeah, I was with my kids at the Royal Ontario Museum. We don't have to mathematize this right this moment, but it's a coin that is worth $1 million. You could do something with that. And because we're getting to the end, this is the part, so follow the link that's just about to come for the Google Doc. Paste your picture in it. So if you're not on mobile but you have Google Photos, that's just Control-C, Control-V. But perhaps you just wanted to find a picture on the internet. Maybe there's something we talked about tonight. Just put something in the slide deck. If you want, in the sort of slide notes or in a text box on the screen, put some potential questions. But for these few minutes, just let yourself mathematize some pictures. I personally, if it was me, I do have Google Photos. I'm going to open it up. iCloud if you have it. Your phone's camera roll, I don't know how, if you'd be able to get them into this environment, but you can try. So let's see if we have that link. Yes, so the link to the Google Doc is there. So head out for a few minutes and put some things into that Google Doc. I'm going to be monitoring it. I'll maybe screen capture something to make a point. Oh, the other thing is it says, yes, click insert and put in a new slide. That's easiest. There's some that exist from a previous session. That's okay. It's just more for the mapping. Yeah, there's a handful. Ooh, amazing array of Smarties. I believe they're Smarties, and I'm going to fill this few seconds of time by saying that I learned yesterday that rockets that we have, those candies, they're just pure sugar in the little tubular roll that kids get for Halloween, are called Smarties in the UK. And there's some, obviously, Smarties that we know as Smarties are protective of their name, so some kind of copyright dispute. Yes, rockets are called Smarties. Can be the king of random facts. That's a pretty cool infinity. Oh, and there they are, the Smarties that are also rockets. I don't know what Smarties are in the United Kingdom. So that could be a classic how many. It's actually, it's that whole unitizing array thing again. Screen capture that one. Yes, okay, let's... Oh, I think people knew my random fact about Smarties, which are rockets. I dropped the rockets into Blackboard because how many? But then I'm thinking unitizing. So that unit, if the unit is a tube of rockets, how many are here? And they actually, like, my secret is I'm not supposed to like those because it's just a tube of sugar. But anyone who has young children knows that your children get, the tax collector comes after Halloween. So this tax collector always looks for Reese peanut butter cups first. But I'll take a few rockets as taxes, you know, for being their dad and all. But so I've never actually thought in all those years of eating rockets, how many are actually, like, what's that unit? Is it 12? And I could look closely and count, but I'm just letting myself wonder. And as a matter of fact, they're asleep, so I may go steal a package of rockets while they sleep right after this. Just as a few people drop their thoughts into the Google Doc, we'll just look at the chat box. I haven't used question formulation technique from Write Question, but it's a great routine for students to generate questions. And just as others finish up their thoughts, because we're reaching the end, we want it to be so you feel like if you're tired, you're starting to feel like you can head off. So the next slide shows 3 very visual amazing things. Visualpatterns.org, whichonedosn'tbelong.ca, fractiontalks.com. Probably you're familiar with which one doesn't belong. So I'll just highlight 15 rockets. Wow, in the package. Okay, I gotta go steal some of those. And so fractiontalks.com has a bunch of fraction provocations. And so there's a whole section just for flags. And so when did you ever think of the flags of the world being about fractions? Maybe you did, but you're probably a math teacher or a flag designer in that case. But I'll just highlight that for a sec. And here, this instructional coach I know has, actually she likes flags. She has flags of the world. But there's one. So reasoning through what percentage is red, blue, and white is interesting. But yeah, when it's just the cross in the middle and different size rectangles in the corners. We'll finish up with some more examples because we want lots of examples to illustrate our point. Sometimes you go to the PD session and you just get, okay, one task, and then if you can't transfer that one task, there's no other takeaways. Takeaway tonight is the mentality. You can come up with questions, you know, and I focused on pictures, camera roll, and so on, but it doesn't have to be that. So feel free to keep finishing with the Google Slides. Pull that into your own drive, make a copy, whatever you need to do. And I'll just talk through the last couple examples I included. The Tim Hortons cup has to do with probability, and that's a pretty big idea. So if the visual information in the picture says that I've lost 6 in a row, if you look closely, you see that. Should I be winning again? So the idea there is that some kids will say yes. Oh, well, and that's because it seems like you should. It seems like it has to be true, but it doesn't. So the Minecraft cubes. Minecraft's good for making patterns, but snap cubes are even better if you don't have iPads. But it's the 1 by 1 by 1, 2 by 2 by 2, 3 by 3 by 3. So it's the cube numbers. That's what that one is. This one came from our Costco math, and so with Halloween just passed, it was big bars versus small bars. And actually, that's like a common, let's call it genre of task, because big containers a lot of times will be cheaper than littler containers. And that's just interesting to know about. And then what type of foods does that not apply to? What's a fair price? This actually had to do with, you'll notice it's the healthy potato chips. I just was outside this was where this mentality started. I looked at that and I said, and I was hungry, and I'm like, I don't want to spend $1.50 for 32 grams of potato chips. That seems ridiculous. Kids had crazy thoughts on this. Some kids consulted like 22 grocery flyers, like on flyerlands.ca. So one kid said, and you don't forget this, she said, this package should be worth 27 cents. I'm like, oh yeah, that seems about right. But it's $1.50, so it could be worse. You could be at the Air Canada Centre for a hockey game buying a beer or something. Anyway, so this conception of fairness kids played into. Oh, patterning, you would have seen that in the Google document. Different types of patterns. The transformations, I don't know what this was, but you could take pictures of like tile floors. I don't know if the floor of your school is interesting. It's probably like the generic 1-foot tiles. Maybe you could do something like that. Mosaics, you know, mosques of the world. So our go-to for a lot of the patterns is Islamic art. Tessellations is Islamic art. Tiling the plane. So lots of beautiful art about that. Dan Meyer partial product was a classic because it was $3.29 for 6, but there's only 5. And I think that's where it kind of intrigues you. Why somebody buying 5? And how are they going to sell that? Yeah, about how many friends could you feed with this Skittle cake? We might want to give 1 dimension. It depends what kids you have. You might want to give 2 dimensions. Depends on your curriculum. One of my favorites that I use now and I tried to pose in front of a whole gym full of kids. So the room was the gym, and I'm like, okay, how many centicubes would fill this room? And kids were coming up to me all day, and they're like, oh yeah, 1 billion, 1 million, 1 billion, 1 trillion. Anyway, in our classrooms, we wouldn't need a picture because we could hold that cube. And this was a classic. It was the quarter of the cross, but it's divided into 5. That's just a task that's out there. It's a great one. I think I'm leaving you with this, which is how many trees are in Canada. So I use this as like the most broadest Fermi question, where it's estimation. It would be in the trillions. It would be in the trillions, but we have no way of saying for sure. And I just posed it as a big open thing. We could do some kind of like per square meter, look at all the cities, zoom around. I don't know if we would. It's just an order of magnitude thing. So I wanted to say, yeah, so the Google link's there again. Take that away, any of these pictures. But mostly it's the mentality. So my easiest way to reach me is by Twitter. And then I included personal Gmail as well. Like, it's just the mentality. It's just, let's find the math in the world. It's interesting and it's fun. So go steal your kids' Halloween rockets. Go open up the fridge. Go to Costco tomorrow. Go take some pictures of some gas signs or whatever you have to do. Go up and have a cookie and notice how neatly arrayed they are in the tray. Take a look in the egg carton and check that fraction. Bring it to class tomorrow. But thank you very much. Have a lovely evening, and yeah, feel free to continue on Twitter or email.
Thanks so much, Matthew. Really great session again. Fantastic presentation, full of improvisation and creativity and questions.
Oh, that was fun.
Yeah, it was a lot of fun. And I love the questions that were like almost philosophical or at the very least quite controversial, like Debbie's question, why does Tim Hortons charge $1.77 for medium coffee when they know we only pay $1.75? So I'm wondering if that's the beginning of a new conspiracy theory. Conspiracy theory.
Yeah, for sure. Why are we getting ripped off?
And you know, my kid spends a lot of time online, like most kids these days, and I keep telling him that the real world is out there, but I'm suspecting that he doesn't believe me anymore.
Yeah.
And also, I loved when you made a reference to the thickness of a piece of paper, because it reminded me of my grandmother back in Belgium. She used to make pancakes. In French, we call them crêpes, and they are very, very thin. They're not like the thick pancakes here in North America. And I swear that hers were so thin that they only had one side. That's what I believed. Anyway, it made a definitely great fun session tonight, and I want to thank all of you for being such great participants and for sharing your ideas along the session. And also want to do a special send a special thank to Debbie, who seemed to have been on roll tonight and brought many interesting questions and many observations. In fact, I noted that many of you kept referring to her comments and throughout the evening, and that's, to me, that's really the quintessence of a successful OTF Connect session, when you guys all start dialoguing and provoking each other and coming with creative ideas, etc. You know, that was really a lot of fun. Anyway, if you can give me another 5 minutes, I just have a couple of slides that I quickly have to show you as part of my duty as a moderator. As Matt mentioned on Monday, there's a great session on fraction by Jonathan Searle.
Highly recommended.
Yeah, and it has a clever play on words. I'm sure that you appreciate it. It's the may the fourth be with you. I think it's really nice.
I've seen it already. It's great. Join. I've seen it already. It's great. So join.
Okay.
So
there's still space for it, so definitely you guys can join. Then on Tuesday, I know that it's not really in your line because you guys are math teachers, but on Tuesday we have our first French session of the season with Jen Rochon, and we only have a handful of French sessions every season, so if you happen to know French teachers, please tell them about this opportunity because we only have like 2 or 3 at most each year. And then on November 13, there's a session dedicated to Google Suite with Carl Kitchen, and we have lots of space available for that session also on November 13. So I warmly recommend it, and I'm going to quickly paste the links to our calendar and as well as our past webinars in the chat box for you guys to explore. I also want to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. And I'm going to paste that link as well if you want to apply. And 2 more slides. One slide just to invite you to provide your feedback. It really helps us a lot to design our future presentations and also to obtain subsidies from the ministry. So when you're quitting Blackboard, you will be presented with a feedback survey. It doesn't take very long to fill it up, and then afterwards you're going to be presented with a certificate of participation, and you just enter your name and you will be able to then add that certificate of participation to your professional resume. And this is typically available for about 48 hours. So I encourage you to do it either tonight or tomorrow when we send you the link with the recording of the presentation and the feedback survey, the questionnaire, and all the resources that we have shared with you tonight. So that's it for tonight. Oh, sorry, I forgot. I should maybe quickly share with you the 2 links for the feedback questionnaire and for the survey in case you're not redirected automatically. And I'm also going to share with you the link for tonight's presentation. It's not live yet. I'll complete the page later tonight, but it will be live by tomorrow morning. And I just want to remind those of you who have already registered that there's a great seminar, a great what do you call it? Conference, that's the word I was looking for, a great conference at the Holiday Inn Airport this weekend, and I think it's going to be a lot of fun as well. So I'm now going to end the recording of the session. Please feel free to remain online if you have additional questions for Matthew. Otherwise, I wish you all a very good evening, and thank you once again for your participation in tonight's session, and we certainly hope to see you soon on OTF Connects again. Bonne fin de soirée à tous et à toutes, et à bientôt sur OTF Connects. Merci beaucoup.